Hey everyone, and welcome to another episode of Mrs. Ross Does Math. This is the first episode of 2021. Welcome to a brand new year, and welcome to our second lesson of Unit 4. Now remember, we are skipping Unit 3. We're going to come back to that at a later point in time. I don't like how our book flows with Unit 3 before 4, but once again, we will come back to it. We'll just come back to it at a later time. For this lesson, and actually our next lesson, we are going to be focusing on Lesson 23. I've broken Lesson 23 down into two different parts. Today's lesson is going to be about Part 1, and this is going to be an introductory level to one-step equations, and that is what we are going to be covering. All right? Now, our essential question, which once again, you always want to make sure that you write that down, is how can I use inverse operations to solve one-step equations? So we are going to be taking a look at that, and here we go. Now, one of the first things that we're going to want to do is, we kind of need to have an understanding of what inverse operations are. Okay, now inverse operations are operations that use opposite mathematical properties. What that means is this: if I have subtract and add, my opposite of addition would be subtraction. My opposite of subtraction, or if I see a negative number, would be addition, or a positive number. I'm going to add that on here. Okay, so we're going to use the opposites to help us solve these problems. Now, just as how we have opposites with addition and subtraction, we also happen to have opposites, or an inverse operation, with multiplication and division. So when we have multiplication, our inverse operation is to divide, and when we have division, our inverse operation is going to be multiplication. So what we're going to do here is we are going to use these inverse operations to help us get rid of a number, because we only want the variable, and then we're going to use that to help us solve for our problem. Okay. Now I have these two examples here. Our first one is a plus 14 equals 41. Now here we have addition. Now the opposite of addition is subtraction. So I'm going to want to minus a number. Now our whole goal is for a to equal something. We want a to equal something. So I need to get rid of the number that's next to my a. And in this case, the number, when I draw my little squiggly line here, that's on the same side as a is 14. So this is the number we want to get rid of. Now the opposite of plus 14 would be minus 14. So we are going to minus 14 from this side. And now one of the amazing things about inverse operations is what we do to one side, we have to do to the other. So because I minused 14 here, I have to minus 14 from my 41. Now, all I'm left with, because those cancel out, is a, and 41 minus 14 is going to give me 27. So a is equals to 27. And that is my answer. Now, one thing we are going to want to do is double check our answer. Okay, so I'm going to put a little check mark right down here. And I'm going to plug my 27 in for the letter A. All right? So now instead of A plus 14, I'm going to have 27 plus 14, and I want that to equal 41. Now again, my whole goal is for this side right here to equal this side. I want my equations to be balanced. So 27 plus 14 is 41, and this is 41, so we get a happy equation. Everything balances out. Now for our next question over here, on our other side, we have -6 plus m equals 13. Now once again, I'm going to draw a little squiggly sign so I know what is my extra number that I have to get rid of. Now again, we want this to say m equals, because we want our variable to have a value. So here, our extra number is the -6. What's the opposite of a negative? It's a positive. You got it. So here I'm going to add 6 to get rid of it. And what I do to one side, I have to do to the other. So I'm going to add 6 there. Now my 6's here are going to cancel out, and I'm just left with my m. And then I get 13 plus 6, which would be 19. So m equals 19 would be our final answer. Now remember, we have to check our work. We want to make sure that the answer we have is actually the correct answer. And this is super important, especially when we've got decimals or fractions that we're working with, okay? So once again, instead of the m, I'm now going to put the number 19. I'm substituting 19 for the letter m. And I'm going to go -6, because I'm checking here, plus 19 equals 13. And if we were to look at this on a number line, and we were to visually see the number -6, and we were to add 19 to that, we'd go towards our positive side, and our answer would be 13. So I get 13 equals 13, and once again, we get a happy answer. Now, pause here if you need to go back and watch any of this all over again, because we're about to move into the multiplication and division part. All right? And again, please feel free to pause this, rewind it, go back through, do whatever you need to, so this is 100% understood. Now, here we have two multiplication and division problems. Now remember, the opposite of multiply is to divide, and the opposite of divide is to multiply. These are my inverse operations. All right? Now, what I have here in my first problem is -4 equals y over 3. Now, our answer, or the variable, is not always going to go ahead and be on the left-hand side. Sometimes it's going to be on the right, and that's totally okay. What I'm going to do here is I'm going to figure out what number is on the same side as my variable, and how can I get rid of it. So here, the 3 happens to be on the same side as my variable, and I only want this to say y. All right? Now, y over 3. Does this over bar also mean something in math? It does. And what mathematical property does it stand for? Division. Perfect. So this means division. Now, according to our signs up top here, what is the opposite of division? It's multiplication. So here, I'm going to go ahead and multiply by 3 in order to get rid of it. And I'm going to multiply this side by 3 as well. Because once again, what I do to one side, I have to do to the other side. Now my 3's cancel out, because this is secretly 3 over 1. And 3 with the diagonal to 3, those cancel out. Okay, so now I'm just left with my y, and I go 3 times -4. Well, 3 times +4 gives me 12, and I have a positive times a negative. Ooh, that changes my sign. This now becomes negative. So I get negative 12 equals y as my final answer. Now, are we done yet? No, you're right. We have to check this. So now I'm going to check my question, and I'm going to rewrite this. And I'm going to go negative 4 equals, instead of y, what number would we put? Negative 12. You are correct. So I'm going to go negative 12 divided by 3. And negative 12 divided by 3 would give me negative 4. So negative 4 equals negative 4. We get a happy answer. Perfect. All right, now we have one final problem here, and this one's a bit tricky, and I put this one on here for a reason. Okay. Now, we've got 9 equals negative e. Is there any multiplication or division in this problem? There happens to be some multiplication here. Now, how many e's do I have? I've got 1. So this is actually negative 1e. Now, any variable that we have has to just be that letter. It can't have a negative or a number in front of it in order for it to equal something. So we have to get rid of that negative 1. Negative 1 and e are connected together through multiplication. So what's our opposite of multiplication? It's division, you bet. So here, I'm going to divide by negative 1 on both sides. Now, my negatives get to cancel out, and I'm just simply left with e, my equal sign, and then I get 9 divided by negative 1. Well, 9 divided by 1 would just be 9. It would be itself. And then I have a positive divided by a negative, and according to our negative tic-tac-toe, a positive and a negative, it gives us a negative. So our answer would be negative 9 equals e. Now, if you notice on here, I'm circling my final answers, and the reason why is because I want to distinguish between what's a check, what's my work, and what's my answer. So as you're going through this, make sure that you square or circle your final answers, and it's all nice and neat together for me, okay? Next, our final thing is we have to check this. So I'm going to rewrite this. I'm going to go 9 equals negative, and then my e, because my e and my negative are so close together, I'm going to separate them by a parentheses, because that also, once again, means multiplication. Now here, I have a negative times a negative. Because remember, this is negative 1. So I have got negative 1 times negative 9. A negative times a negative gives us a positive. So we have 9 equals 9. Our answers work out, and we are good to go. All right, now at this point, we are done with our examples and our notes. If you have any questions at all, please reach out to me, ask me a question, send me an email. I am here to help. Pause this video, rewatch it, do whatever you need to. Several of you have asked about some extra credit opportunities, and I do have something called the one-step equation song that you can go ahead and learn. I will tag that video to this one. It is already posted on my YouTube channel, Mrs. Ross Does Math. And if you were to go through and learn that song, which happens to be the tune of If You're Happy and You Know It, and you sing it to me, you don't have to sing it in front of your classmates, but if you were to sing it to me, that'll go ahead and erase an entire assignment for you. So go ahead, give it a shot, and remember, if you have any questions at all, please reach out to me. Thank you so very much for watching. This has been Mrs. Ross Does Math.